So thanks, Ani. So welcome to this masterclass on learning AI through Bollywood. Now, this is going to be a very interesting topic because it mixes technology and entertainment, very unique combination. I will introduce today's guest speaker, Ajit, shortly. Before that, just let me introduce quickly OMPEG, the organization behind organizing various seminars, webinars in the UK. OMPEG is a fee-based membership organization for UK-based Maharashtrian professionals and entrepreneurs. We have around 150 fee-paying members. We started this organization in April 2016 and organized around 50 value-added programs, including 2 business expos. We have 30% members who are female and all are entrepreneurs. So this is about OMPEG. We'll be sharing the link about OMPEG and OMPEG's membership page for you to access and join OMPEG during the session. Coming back to Ajit Jaokar. Ajit Jaokar is an expert, a global authority in the field of AI. He is a course director for AI, cloud, and edge implementation at University of Oxford. Recently, he has successfully started a membership program comprising of AI enthusiasts around the world. He is truly considered top 100 influencers in the field of AI and is going around the world now through webinars, but otherwise he literally travels around the world to share his knowledge, wisdom, and skills and expertise in this field. I just wanted to give some ground rules about this webinar. We'll be keeping all of you on the mute throughout the webinar. If you have any questions, queries, comments, please put them in the chat window. We'll capture them, and towards the end, you will get an opportunity to ask the question to Ajit. So with further ado, I will now hand it over to Ajit to start his masterclass. Over to you, Ajit.
Thank you, Ravi. Thank you, Ani. Hello, everybody. Good evening. Good evening, at least here in the UK. So I'm going to first of all share my screen. Yes, and we are going to share this screen here, and we will do it this way. And we come here. Okay. Cool. Do you see my screen? Yes, very good. Perfect. Yes. Good. Yeah. So I like this Gabbar Singh thing to start off with, actually, because I found it yesterday when I was seeing that. And it says basically, Samba Dekho Bollywood bhi data science kar raha hai. And I think that this is a meme I like, partly because it helps us to understand a very difficult subject like AI in a context which all of us know. Yes, and that is the objective of this whole session. So in the sense that I'm not expecting you to be experts in AI, but at the end of this session, you will know a lot about AI. And if you are interested, we will share code and other things with you as well. And I will share you in the chat session. I have sent a link where you can register yourself and we will share your code. But in this case, I'm keeping it complete to the problem domain statement with that. So the original idea of this one was 2 things. First of all, it was to teach my son about coding and things like this. And also, if you know the Garje Marathi mentoring program, which I'm also involved in, I also wanted to share this idea with the companies I'm mentoring with that, so that they can learn as well. And of course, the OMPEG approach was there as well. So I started to keep the idea very conceptual, but we will go into a lot of detail. And I will tell you why this is a very good problem domain. Other than that, most of you know it already in some shape or form. A couple more things about me. So as Ravi has kindly introduced me, I'm mostly known to most people through my work at Oxford University, which we run a very complex course called AI Cloud and Edge Implementations. I also have an entrepreneurial side. So I have my own startup and I own consulting company. And I'm also on the board of some interesting advisory board of companies like Digity in Germany and Castellium, which does cybersecurity out of New York. So I have a very good background of, rather unique background background of sort of looking at academia, consulting, as well as a startup. So it's a sort of reflecting on that. And also AI can be very complex. So this is a company we work with in Oxford. It's called Actoris. Actoris basically does drug discovery, and they're doing some amazing work. And Martin Bittner, Professor Martin Bittner, is a Rhodes Scholar. He's also a visiting lecturer in my course. He's also from Oxford University. So my point is that much of these ideas I'm talking to you are in very simple context, but the application can be very, very complex indeed. And in many cases, if you understand the concept, you will understand how to apply it in a different idea. And so we're starting to apply it to a problem of movies, Bollywood movies specifically. I also always start with this slide when I teach, and it's sort of a Newton's concept, which says that how little we know, and AI is a subject like that. I mean, it's a constantly changing subject. In the last few weeks, if you follow things like GPT-3, and you will see that it's become a huge thing. It's only a few 4 or 5 weeks old, almost, I would say 4 or 5, couple of months old, but it's a new thing which has come out and everybody's talking about it. My point is that every 4 months, 5 months, 6 months, something comes along which completely changes the game with that. So I think that this is where we come to look in that. And of course, this is what I teach in Oxford. We have gone online, so it is possible for people to sort of join this if you are interested with these sort of things I teach. And this is my consulting company. We also have a very interesting idea where I teach AI on maths foundations if you are interested with that as well. So the roadmap for today is, first of all, we're going to learn the concepts. We are focusing on problems. We are looking at movies and specifically Bollywood. And then I will show you links about the coding session, which we will not go through today. So my point is, I'm hoping that we will get time for Q&A today so that we can kind of understand more details about what we want to learn with. And of course, I mentioned to you the motivations with this, and this is the link which I have also put in the chat. If you do want to enter your name from here at any time afterwards as well, I will share with you afterwards the GitHub repository, the notebooks, the code and things like this. So my original idea was to run it through completely code. However, I think that because we have such a wide group of people here now, I have kept it more at the problem level, at the conceptual level, and then we will discuss the coding afterwards. Really, I mean, if you're interested, we can continue on with that. So let us start about AI. Yes. So when people think about AI, they think about something like this. Yes. So they always think about job losses and things like that. And that, of course, is partly true. And also they think about this idea that they think about the sort of the AI will take over the world and the sort of Arnold Schwarzenegger Terminator type discussions. Yeah. But I will explain to you AI in a very simple slide, almost one slide, which is this slide. And what I'm trying to tell you is that effectively, I'm trying to tell you that think about it as rules. Yes. So given a problem domain, what are the rules for the problem domain? Yes. So this is the simplest way I can explain AI to you. And how can you formulate the rules? The first way is to do explicitly encode the rules. Yes. So by this, I mean that you do if then else statements as you do in coding for each and every scenario for the rules. This is the first way. The second way is that you learn the rules from the data, and this is machine learning. Yes, and which is primarily what we are going to look at today. So machine learning is sort of the same category as artificial intelligence. Yeah. The third one is that when you run the rules and the structure of the problem from the data. So this is what you come to deep learning, which you start getting more into AI. And the final one, which most people are not familiar with, is you learn rules by trial and error. This is the sort of thing which Google is doing with reinforcement learning and stuff like that. So almost forget about AI, forget about things like that. Think about it like a lion trainer timing a lion, and try to find out how can you train an algorithm? How can you understand the rules behind a problem? And if there are these are the three ways to understand the rules. The fourth way, of course, is learning by trial and error. But if you understand those three ways of understanding rules, then I think that you've gone a long way towards understanding the problem domain of AI. Yes, what are you trying to solve? The second thing about AI is that AI is involved in solving problems which are not in the finite domain. So a finite domain problem is the one on the left hand side. Yes, so chess is a finite domain problem. When you look at a problem like chess, actually, if you look at, I mean, we are quite a few of us are a bit older, but I think that if you look at the 1970s and things like this, then you look at the sort of the Gary Kasparov versus IBM situation where IBM's Deep Blue defeated Kasparov. And in that situation, what you do is it's a problem like chess, it's easy for a computer to solve. And the reason why it is easy for a computer to solve is because it's the world which is finite. A finite world means that you have an 8x8 chessboard and you can figure out the rules for that problem quite easily because there is a limited world of chess. Yes, so every piece behaves in a certain way. Every square has, there are only limited number of squares. But another problem on the right hand side is identifying a dog is actually what is an infinite domain problem. An infinite domain problem is because it's a problem which has too many variants around a single concept. So concept of a dog has many different variants to it. For example, the dog could be big, the dog could be small, the dog could have hair, the dog could have a longer tail, shorter tail. It could be of a different kind of a breed. It could have a collar and things like that. So it is not easy to identify a dog given certain characteristics. The idea of this problem is that even a child can understand this problem, but what we are trying to do is to try to find out the rules which make up what is a dog. Yes, so this is what I mean by trying to understand both the structure of the data as well as what the problem is. And that is what AI is all about. That's what deep learning is all about. How does that happen? That happens to a neural network. The way neural networks work is that they work in this way. They work bottom up. They work similar to the brain works, and that you have lots of examples of something and you keep training the neural network so that it identifies that particular pattern, but you don't tell it what the pattern is. So for example, you can identify a cat, but you do not tell that the cat has whiskers, the cat has a fur and things like this. These are characteristics which the algorithm is figuring out on its own. Yes, so this is the basic idea of deep learning, and that is what AI is all about. Yeah, so these are the definitions we are going to go for. Machine learning is explicitly training an algorithm. Deep learning is automatic feature detection, as I showed you in the previous diagram. Then we're talking about AI, which is artificial intelligence, which is based mainly on deep learning. And we're talking mostly on narrow AI. Narrow AI means that we are talking about AI in a specific problem domain, and general AI, which is still the realm of science fiction. Yes, so still general AI is something which people are still talking about in a kind of a futuristic perspective within there. So our world realistically fits around these. And the reason I say that is because there is too much hype around this subject. So this is the first point. The second point is that we are here to solve a problem. Yes, we are not here to talk about the end of the world. We're not here to talk about kind of futuristic scenarios. We are here to see a problem which we are going to face in our lifetime and try to understand that. And this is why I explicitly state these definitions, because then we can look at Bollywood. We can say what the problems are in that industry. The other thing about AI is that it is affecting everything. Yes, and this is the slide which I picked up, which we use in Oxford. But the point here is that this is the world which is absolutely affecting each and everything. There is almost nothing which is not impacted by AI. And somewhere here on the left-hand side is entertainment, and that's going to be our world for today. But my world realistically is fetching into many of these areas. So including autonomous vehicles, that type of stuff, because at Oxford, we look at AI and edge computing. So the world of AI is quite complex, but we have to narrow it down within them. The second thing is AI is not a single job. So AI is at least 3 jobs, and I'll explain to you a little bit more about this point. So AI, the 3 jobs are data engineer, data scientist, and DevOps. And most of the world is, our world is the data scientist world. So we are involved in creating an algorithm, but there is a data engineer who is involved in the big data Hadoop side of the world. And then there is the DevOps world, which is the sort of the building and deploying onto complex structures within there. And this creates a whole different set of problems, which again, we tend to face quite a bit. So if you heard of words like Kubernetes, which are involved into DevOps, so in the production situation, you don't just have to train your model, but you have to deploy it into production using the DevOps architecture. So AI is not separate from the traditional computer science world. And I'm saying this to you because this is how your world would look like. And of course, you are trying to solve very hard problems. And this is important because it is not an easy subject to solve. And before I come to the whole Bollywood point of view, what I'm trying to tell you is that there are many ways to solve a problem. And this approach is needed for certain reasons. Yes, I mean, this is something where you can't solve it very easily. And I also like to show you something like this, which shows you the difference between traditional programming and machine learning. So this was the same idea which I talked about before, where I said that AI is about rules. Yes, so the output of a machine learning algorithm is rules. Yes, and the input of the machine learning algorithm is data and outcomes, meaning that you have labeled data. Yes, so I have a certain experience of something. I have a labeled data set, and I can tell you what the labeled data set is, and from the output of that is come the rules. Yes, but the traditional programming is different. Traditional programming, you have the data and the rules, and from that you get an outcome. Yes, so because you are explicitly telling the rules. Yes, you are explicitly saying what my rules are, and from that I'm getting an outcome. Yes, but in machine learning or deep learning or AI, you are effectively finding out the rules, which brings me back to the same problem which I was talking about here. Is the whole problem of AI is finding rules, hidden rules behind something. Yes, so this is where, and that's where I'm going to lead to the Bollywood point as well. So the way it works is quite simple, and it realistically works in the same flow. So you get your data, you have a hypothesis, you create a model being defined, and an algorithm trained on some data, and then we interpret the results within that. And the way it looks like is something like this. You train your data, you have a data set, you have a model, and then you get some hidden new data which you have not seen before, and from that you make a prediction. Yes, now I'm going to come to Bollywood very soon with this one. And of course, your world gets a bit more complicated because you also have far more things to worry about. You have many different type of statistical techniques. You have many different type of computer science techniques. Yes, so I won't go into all of them, but these names are familiar to you. Many cases: Hadoop, NoSQL, streaming, in-memory, Spark, Scala. You throw all these things at it because they all apply to certain extent of AI. And then you have different data formats, and typically AI is involved in the unstructured data sets. So you have image, video, text, time series, that type of stuff. Yes, so you are sort of effectively kind of leaning to a different set of problems. And then finally, you have modalities. Modalities meaning that how you deploy something. So you could deploy something using cloud, around edge, using DevOps, using CI/CD, and many of those things with that. So where you are coming from here is that it's a complex world, but it is still a world which is familiar to many people. So one of the things we're going to talk about today is sort of algorithms. Yes, and I'm going to apply them to Bollywood. So we're going to talk about what are the typical algorithms, and these are actually quite a few of them coming from statistics. Yes, so there is classification, where you have a group of things, you separate them into groups. You have regression, where you're trying to find out a hidden pattern, trying to find out, in this case, a line which passes through all these ones. You have attribute importance, you have anomaly detection, which is trying to find out outliers. Then you have clustering, you're trying to find out, separate something into groups of people, and so on and so forth. So these algorithms are actually quite similar across history. And in our case, we are going to look at some of these algorithms on Bollywood data sets. And I'll tell you why Bollywood data sets. I'll also tell you why something like Netflix, if you are a member of Netflix, many of us are, will tell you why that is the future. Because Netflix has got AI built inside it, and I'll tell you why that makes a huge difference with that. And it's also making a big difference to the entertainment world as well, because what Netflix is doing is Netflix knows through AI and machine learning, it is impossible for the Hollywood theater to know, or even Bollywood theater to know. So this, whatever I'm describing to you is fairly simple, but its impact is very, very big. So don't think of it as a simple kind of a Bollywood problem, because the exact same thing applies to many, many things with that. So the approach we are taking is, again, problem solving. And the regression algorithm, which I mentioned to you, is concerned about primarily modeling relationships between variables. And I'll explain to you again in the Bollywood. But the problem is, it looks like this. Yes. Your job is to find out a line which best represents a set of points. So this is fairly straightforward math stuff. So whenever you have a set of points, your problem is to find out the equation of this line. Of course, this may not be a single line. It could be a curve, but the point being the same with that. The second one is classification. So given a set of points, your goal is to find out how do you find out line which separates these two things. So the problem we are going to look at is hit versus no hit in Bollywood. And in the case of, if you are interested in the coding side, I will actually share the code with you, but I'll explain to you how this works and how you can solve this problem. So the problem, if you look at this problem in Bollywood terms, this is a question of trying to separate a hit versus a no-hit movie. And the importance, of course, is that there are many different attributes which cause a movie to be a hit or not. Yes, so this is the important point. The point is that, and that is what I'm going to come down to with Netflix, with Bollywood, with all sorts of things, so that this is not a simple case where you have a small number of parameters. You have a very large number of parameters which would affect the outcome of something. So this is where we kind of come to with that. When you come back to the regression problem again, the regression problem involves finding out the gross earnings of a movie. Yes, so if I look at a movie, how do I predict what its earnings would be? And I could do that based on, if I'm able to find out this equation based on a large number of parameters historically, I could say that this movie would earn this much amount at a point in the future. And this is what I'm trying to do largely within that. There are some other algorithms, for example, clustering. So I might be able to find out groups of things which are related. So I might be able to say that, okay, these movies are related to each other. And if they are related, then maybe if I'm buying one of them or I'm seeing one of them, maybe I will like another one. So this is how Amazon works with that. So this is a clustering algorithm, and this is how this would work as well. So many of these algorithms, they manifest themselves as traditional features in our case. So we see them as something, but of course what you're seeing there is that those algorithms are historically created from there. And then we come to the whole idea of the deep neural network. The deep neural networks, they are based on working through the brain. They work like neurons. So they have input neurons, output neurons, and hidden neurons. And this is how the structure of a deep neural network works. And a deep neural network is something I showed you before in this diagram here with the structure of the woman. So deep neural network looks like this. Yes, a deep neural network really takes sort of inputs of images, and you filter them at every layer. So the lowest layer detects pixels, the layer above detects contours, the layer above detects edges, and so on and so forth. So every layer builds upon previous layers. And ultimately you get a classification or something. But what you're getting at is the characteristics of this as well. So you don't just get that this is a woman or not. What you're saying is that a woman has certain characteristics. These include wearing the headband, wearing these eye goggles, and so on and so forth with that. So what you're trying to do is work bottom up. You're trying to work bottom up because they're trying to find out not just that this is a woman or not, you're trying to find out the characteristics of the thing. So in this case, if you take the example of the child, then you're not saying that this is a dog or not. You're learning that the dog has certain characteristics, which include the fur, the sort of the nose and things like that. So this is the whole point about deep learning, is that it does learn not just the nature of the data, but also the structure of the data. Yes, so we were here at this point. And the rest of them, but mostly we are doing a classification problem. Yes, we are doing typically a classification or a regression problem, no matter how complex it is, because what you're trying to do is trying to find out how something applies. And this, again, I'll come back to the same movie scenario with this case in that. before we go to movies, I'll go to a simpler example. Sorry, before I go to that one, I will show you one other point with this one here. And that is to show you, I'm going to switch my stop sharing now and share another screen here. The reason I'm showing you this is because I like to show you this. I like to see these sort of pictures where they say you are here in the galaxy, yes. So what I'm trying to show you is how big the world of AI really is, yes. And then I'm going to come back to here to this one. I'm going to stop sharing in a minute. Yes, I have got another thing to share with you, and I've done this before, so don't worry about that. I will quickly share this one here. And now, do you see another screen, Ani? Yes, good. Yeah. So this looks like a bit of a mind map, and it is a mind map. It is not a mind map created by me, but it is an excellent mind map. And what it shows you is how the world is quite complex when you kind of look at this stuff. Yes. So if we are looking at ourselves that this is what is called an ML engineer, so machine learning engineer. Yes. So you're looking at sort of programming language. This is where we are at. Yes. So we are programming something, and then there is Python as a programming language. Yes. But then there is a whole bunch of other stuff like cloud computing. So we look at in Oxford, a lot of cloud computing. And then there is the DevOps world, which is also the Kubernetes and the Docker and databases and things like this. Yes. So this world starts to get more and more complicated as you go along. And then you go along to other things. For example, you do some of this. I don't know. My point is that I don't know all of these things. But many of these things are quite valid, depends on which part of the world you're looking at. So then you come to this whole MLOps business, which is what I was trying to tell you about before. Then you do this whole Spark and Apache Airflow and those sort of things with that. And then you do this whole complicated thing around deploying on specific hardware, which is like a GPU, TPU, CUDA optimization, OpenCV, that type of stuff. Yes. So my point is that AI is a very complicated subject. This is why I talked about that Newton example in the before thing with that, is that the world of AI is not only complicated, it is growing much more faster. Therefore, to learn it, it is quite much more better to kind of understand where you fit in the world and then try to master your own thing within it. Yes. So I think that we are here almost, we are somewhere here, Python. Yes. And this is what we are going to be trying and understand how this problem can be solved, because we are going to try and build a model. Not today, we won't do the coding today, but if some of you are interested in this, then do email me, do register for that. But today I'm going to talk to you about how this problem can be built with that. Yes. So my point here is that this is how the world looks like when you are doing a professional AI implementation. And that is why it is such a hard job to do. However, sort of from a learning point of view, I almost think you should all understand where the world is and then focus on your own bit of the world, because if you try to do everything, you will not learn anything with that. So I'm going to stop and go back to my sharing my screen now, my original one, so that I've done this before, so I know this quite well. So we start from here. Yeah, here we go. So Ani, do you see the screen back again? Or the one with you're here, okay. So Ani, can I just throw a question at you now at this point? How do you get your movie kind of background? I know we haven't gone into movies yet, but does this sort of make any sense even without looking at movies so far?
Ajit, thank you. First, I didn't know you were going to put me on a spot, but hey, you're a teacher. You're a teacher and you picked up the naughty child. So thanks for that. I mean, well, unfortunately for me, forget gifted with artificial intelligence. I'm not even supplied with any natural intelligence much, but I've understood so far the complexity of it. I was trying to understand all the pictures, words and tables, the word I could process. So I've understood it's a very complex world out there, and you are just at one place. You can't be everywhere. And, even that small bit has many facets. That much I have understood
Yeah,
from my
good.
limited intelligence.
Yeah. But
And,
I guess, yeah, sorry, go on.
now, from the movie background thing that you mentioned, I'm more keen that where does it get applied?
Yeah, which is where we are coming to with that. So I think this is
Thank
where
you.
I was sort of explaining the background, what the problems are, how you can solve what type of problems you can solve. Yes, and that is what I'm coming to with this. And just to recap very quickly, we are looking at solving typically two types of problems: classification, which is here; regression, which is here. And these are the types of problems you can solve. And those include classification, regression, anomaly detection, clustering, etc. Sorry, you have a question, Ani? What is it?
Yes, since you did the teacher thing on me, I'm doing the
Yeah,
student thing
okay.
on you.
Yes,
That
yes, yes.
since you're going through, I mean, we are of course going to, this is an open event. We'll be putting it on YouTube, Ajit, as you know.
Yeah.
If there are any important slides where people want to take screenshots, are you happy to? And what would be those slides, if you don't mind? So then, exam ke pehle.
Yeah, I think
Thank you.
yeah, I mean, this is a good slide. I like it because it does sort of combine everything together. But I guess whatever people want to take with that, I do tend to go back sometimes on the slides, mainly to sort of explain to them what is the significance of some things. So this one is an important one because it kind of explains the point. So that's a good point. I'll sort of stop on certain slides with that. So this one's an important one because it explains the ideas. This one also I think is an important one because it explains the flow. Yes, so this flow of a typical problem statement, which will be our problem statement as well, it will also flow in the same way. So if you are going to look at the coding side, this is what it would be, that you would start to look at some data, train the model, deploy the model, and so on and so forth. The other slide which is important is this one, which again talks to you about what is the difference between traditional programming and machine learning, because I talked to you about the roots, and this is what we are trying to do. The next one is this one as well, because it tells you that in the real world, there are three jobs, at least three jobs: the data engineer, the data scientist, and the DevOps. And typically you are, as a data scientist, somebody who is building an algorithm, you are in the data science world, but you are dealing with the data engineer and the DevOps both together on both sides. Meaning the data engineer is a person giving you data, but DevOps is the person you are giving your model to, so that this person can deploy the model into production. So you are in the middle of those two roles. Yes, you are in the middle of the data engineer and the data scientist, and the DevOps engineer. And then this one's a good slide as well, because it shows you what are the possibilities, what you can do with this one. And then I like this one as well, because this is the definitions. I know, Ani, you took a picture of this one as well. So this
Yes,
shows you
yes,
the
I did.
definitions of what it is. I like to show definitions because I think, like I told you before, people do get carried away with this stuff. They talk about sort of many esoteric things, especially the media tends to
Yeah.
hype up things. So I tend to always explicitly say that this is how I define the world, almost like a scientific paper structure, and then you work from there. So this is how I define the world, and this is pretty much a valid way to define the world. I mean, you can sort of Google that from there. This is another important slide because it shows you how deep learning works. I really like this slide. It's taken from an excellent book by Yoshua Bengio and others, and Ian Goodfellow. And this book really shows you, for me, when I looked at this diagram, I understood what deep learning was. Yes, because deep learning, it shows you, this is the meaning of a deep neural network. Every layer is building on top of the previous layer, and every layer is learning from the previous layer. And in the end, you are understanding characteristics of a problem, so that you do not have to explicitly say what the characteristic is. Yes, so you don't say that a woman is supposed to have these features. We do say that the data tells you that these are the features from there. Yes, and I like this slide as well, because this shows you the problem, the finite domain problem, because the chess is a finite domain problem. It's a problem which was solved by about 40 years ago by IBM's Deep Blue. The problem on the right, a child can do, but a computer cannot do very easily until recently, because it's an infinite domain problem, meaning that there are too many variants around a single concept. Yes, so there are too many variants around the concept of a dog in this case. And this was the final slide I wanted to show you before we go back. And this, of course, shows you what is the whole point about AI as I see it, meaning that it's all about rules. We're trying to find out rules behind something. In this case, we are trying to find out what are the hidden rules which makes a movie a hit. Yes, if I take this idea into Bollywood context, I say that, okay, what is it? What are the factors which can make a movie a hit? Yes, and how do I find those factors? What are the factors which can make? What are the factors which can tell me what is the earnings of a movie after a year or so? And how will I weight those factors? Yes, how will I know what those factors are? Yes, so this is the end goal of what we are trying to do here. Yeah. So now I go back to my previous, where I left off with that one, because I do like to sort of revise stuff, because it tends to be quite hard for people to sort of absorb so many new ideas together at the same time, and this is quite useful to do that. Okay, now we were here before, so we're looking at one final thing before we go into this whole Bollywood discussion, and that is to do with something called features. So imagine if you're trying to buy a house. Yes, so if I'm trying to buy a house and this is the Boston housing data set, what are the factors which influence the price of a house? Yes, maybe the house is near a school, maybe the house has less crime in that area, maybe the building is good, maybe there are a number of bedrooms which are there. So the point is that these features are something which are needed so that you can predict the price of a house. Yes, but quite often you tend to have many different features, and those features are highly complicated. So for example, now coming back to the movie example again, a movie can have many different examples. The obvious feature in a movie case is, I guess anybody can think about it, is the hero. Yes, the popularity of the star, the popularity of the hero or the heroine who makes the sort of hit or known hit. Yes, so you can say that if it's an Amitabh movie with the Shah Rukh Khan movie, this is the characteristic. So the star is a characteristic in the output of a movie. Yes, but there could be many other factors, and this is where we are sort of coming into this whole point about machine learning or deep learning. The idea is to find out which are the hidden factors, and if there are factors which you haven't considered at all. Yes, so this is what we are coming down to. And this is why the problem is quite easy to understand from a conceptual point of view, because it's similar to buying a house. So if I were to buy a house, I would have to look at these typical factors. Yes, but maybe there is another factor. Maybe there is Wi-Fi. Yes, because Wi-Fi now is a critical factor. Yes, but maybe 5 or 6 years ago, 10 years ago, not many people thought about Wi-Fi, but today you would not buy a house where the Wi-Fi connectivity is poor, or the cellular connectivity is poor. Yes, so this becomes a factor in the pricing of your house. Yeah, the other thing to remember about training an algorithm is like teaching a child to walk, or if you're trying to drive something. Yes, the point about teaching a child to walk or learning to drive is that the skill must be applied to something which you haven't seen before. Yes, so the point here is that if this child can only walk on that one road, that isn't very useful. Yes, so if the child has learned something, then the child has learned to walk. The child will learn to walk on any road. Yes, and this is the problem of, this is the case of inference. So when you train it using data, you must train it in such a way that it can understand unanticipated situations. If it is actually doing something which has already seen before, as in this particular road, then it is not very useful, because the limit of what you can achieve with that is very low. Yes, so this is why algorithms tend to be sort of, you have to train it on data which you have seen, but it must work on data which you have not seen. Just like teaching a child to walk or learning to drive. Yes, because you can drive on a certain road, but you must learn the skill in such a way so that you can apply that to another idea. And this learning the skill is actually the question of understanding features. Yes, and this is what we are coming to with that. So features is what constitutes or what comprises the problem, and this is how we look at it mathematically. I won't go into that, but the point is to find out a hidden function. The point is to find out a hidden relationship between that. And one final point before we jump onto Hollywood and Bollywood is that the whole point about deep learning is that it also identifies the features in addition to the data. Yes, so this is what it comes down to with that. Now we come to the movie world. Yes, so I sort of got this thing, Marilyn Monroe thing, with that, which show that there is no business like show business. Now in the machine learning world also, there is this world business of show business or movie business is actually a very good problem domain. And for the reason, because that while Hollywood and Bollywood are a land of intuition, that intuition is not enough for success. Yes, you need a really quantitative element to understand the risk you're taking. And I'll come back to Netflix and tell you why Netflix is sort of a game changer in that regard. The good thing is you have a lot of data, but there is a lot at stake. Yes, so there is a lot of historical data, and the challenge is to capture new data. Then again, I show you why Netflix is so interesting. The thing is, early prediction is important. And the question is, is there a hidden prediction? Is there a hidden factor to the success of a movie? So if I can say that this movie is successful or for certain reason, and then I might say that there was another very successful movie which was launched at the same time. Yes, so this might be a factor which influences the sales within that. Then the traditional factors of a movie are very important. Then they include the stars, the director, the studio, the critic ratings, etc. But there are lots of other factors. So for example, especially in the current world, you can think about how many times has the trailer been viewed on YouTube and things like that. The other thing is at the moment the movies have too many genres. Yes, so historically there were a few genres, but today the movie world has become into much more complicated genres. And then you have sparsity and cold start. So sparsity meaning that there are some cases where you don't have any ratings at all, and some cases where you can't recommend it because it is not related to something else. Yes, so the world of movies, when you look at it from a data point of view, this is something which most of us would know, but it is the same way with that. So what happens there is that now if I look at the world from an algorithmic point of view, there are many ways in which to apply algorithms. I won't go into this one with that, but the point I'm trying to make you with this slide is that you don't apply one algorithm to solve a problem. Yes, you apply a range of algorithms to try and solve a particular problem. This is how, again, the real world works. And if you go to the coding thing with me, then we will see that we will try to apply multiple algorithms to the same problem, so that we will try and find out whether we can kind of solve it in a different way. So typically when people start to talk about interesting things, it's not so simple as just trying to find out using one algorithm. So now this gets very, very interesting with Netflix. Yes, the reason why it gets interesting with Netflix is I believe that the future of the movie world will be with Netflix, because while you are watching Netflix, Netflix is watching you. Yes, because Netflix is able to know everything about you, all your entire behavior, where you paused, where you stopped, where you fast forwarded, whether you liked something or not. Each and every of your interaction is being recorded, which is unlike a movie. Yes, and this in a way, I think that this problem, while I have talked about it as a movie problem, I think this problem is much more interesting and much more sophisticated when looked at it as a Netflix problem, because it is right down the value chain, meaning that I'll show you what I mean by this one. So how does Netflix use analytics? So there are 33 million different versions of Netflix. So this was, I think, when Netflix had 33 million customers. So their director of communication said this point. His point was that it is personalized almost to individual person. Yes, so this was the sort of the holy grail with that. The other thing, of course, is now Netflix has 130 million subscribers, and that makes a huge difference in terms of trying to understand it. And what can Netflix know about you? It can know a lot of things: pause, rewind, fast forward, what you like to watch, what time you like to watch, what is your zip code, what device are you using it on, what ratings you gave, or what you searched for, what you browsed for, and so on and so forth. So I think that the whole Bollywood problem or Hollywood problem of trying to just find out what is a hit or not, when you look at it from a data science point of view, becomes extremely interesting in the Netflix world. And this is the best example of this is House of Cards. So House of Cards is actually a UK based movie. UK-based serial, and Netflix very heavily invested into that to create a US version of that. But they didn't do it by random. And the reason why they did do it at random is because they were observing a few characteristics. So for example, they were observing how many people are watching Kevin Spacey movies. They were observing whether people are watching the UK House of Cards right to the end, and all sorts of things, other movies created by the same director. So as a result of that, they knew that they could invest into a new US version of the House of Cards, because there were a lot of people who would hopefully buy that thing. Yes, so when they took a risk like this, they did not just take it out of random to invest 100 million into that. More important, so what I'm trying to tell you is that the world of Bollywood, or the world of movies, is now two-way. Yes, it is now two-way, because historically it was one way. So people were trying to make a guess about something. But now, because if they watch you very closely, They know everything about you, and they can influence the content with that. And that includes the trailers. So Netflix had 10 different trailers for House of Cards. And it was, even the trailer was customized to you. Yes. So if you are a Netflix customer, I think that this is where it was really interesting, that they showed you a different trailer, depends on who they thought who you were, based on what they saw, and they created different trailers for that. And this is the world of what I mean by how data is going to influence everything, because this problem is actually can be done into anything else, including manufacturing and so on and so forth. It just has come up first in movies and media, but it will come into other things with. And of course, House of Cards was a huge success for Netflix. There's no doubt about that. So my point is that it is not just something which has been made up. It is something which is showing real dollars and cents behind that. So now what happens in the Bollywood world or the Hollywood world, in any case, this is exactly the same way the problem works. And I have already shown it to you before with that. And then you apply different algorithms. This is what we'll be doing in the online session as well with that. And that's what you do. So this is the same thing which you did before, is that you take something, you apply it, you would apply different algorithms, you test it, and you try to predict with something. So now we come to our Gabbar Singh thing. Yes. So now the way we tried to solve this problem, I tried to understand this problem, was take an existing data set, because I just come back to that. So what I did do here was that you take an existing data set from the web, which was from this link here, which is the GitHub link. Yeah. And I took that data set, and from that, I added two more things. For regression, I added a ratio. And for classification, I added the ratio and the status. And I will kind of show you that a little bit afterwards with that. And there are three problems we tried to solve. One is regression, which means the box office tick. The second is classification, which means whether a hit or a no hit. And the third one is sentiment analysis, which looks at the sort of whether the reviews are going to make a difference, or what is the nature of the review. Is it a positive review or a negative review with that? Yeah. So the algorithms we used for each of them was for the regression, we used linear regression. For classification, we use something called SVM. And for sentiment analysis, we use logistic regression. And there are many more problems we can solve. So coming back to the whole Bollywood thing again, the problems we could solve are sentiment analysis, review classification, predicting positive and negative words. We can predict the movie gross box office hits, which is what we did today. Yes, you can predict the movie ratings. You can sort of more classify the genre. You can look at the success depending on certain criteria. You can look at recommendations, trying to understand one movie and which one is good, and so on and so forth. So of course, the way we solve the problem is that you have to start with data. And that is what I did with that. So I took two data sets. The first one was this data set called Bollywood Review Predictions from Yash Raj Films, I think it is. And the other one is from Kaggle, which is a classic thing. And then we added some more sort of features to that data set. And this is the main thing which, if you want to sort of work on the coding side, that's what we will do with that. So we'll take this and try to predict the sort of the sales of the movie, or whether it is a successful movie or not, based on the data within that. So this is what I mean to say, that many of these problems are fairly simple problems in that sense, and they can be understood using that. So now looking at how the data looks. So in the data, we had 703 rows, and the features we had were the movie target, the budget, box office, the rating, votes, and so on and so forth. Here, the box office was the target, which means that we are trying to predict the box office revenue for the movie. Yeah, and this is how it looks like. So these are Hindi movies, Dangal and things like that. Some of which were successful, some of which were flops, and so on. So we took actually the data from this link here somewhere, and then we added some more things to that. So when you actually do this stuff, you actually have to work with real data, as we are seeing here with that. It has 7 features, and like I mentioned to you, this was the target feature, box office, and this is what we were trying to predict based on these other features, which is the budget, the target, the movie genre, and so on and so forth within there. what we tried to do was we load the data, we try to understand the data within there. Then we look for outliers, which mean things which don't fit. And the way you do that is using something like this, which try to find out things which are falling outside the median value of that. Then you try to graph it and try to find a distribution, which is like a typical Gaussian curve within there. Then you do correlation. You do which factors correlate to other factors. If there are some which are too close to each other, then you remove them because they are doing the same thing. Then you reduce the number of factors with that. Then you look at the classification problem. You do something similar with that one as well. Of course, the classification problem is the status is what you're trying to do. Trying to say this one is you're trying to predict whether it is a success or a flop or a super hit within there. And in that case, also you have a similar situation where you have all of these ones here, and this is the problem you're trying to predict. This is the variable you're trying to understand, whether it is a successful one or a failure one within that, and so on. Now with that. And that's what you do again. You do the correlation, and then the final one with the sentiment analysis problem. The sentiment analysis problem looks at sort of understanding the meaning or the emotion behind something. Sentiment analysis is a huge situation now because of natural language processing having taken off so much, and many people are sort of looking into that in a big way. In this case, we took an IMDb data set. We took these are the features within that, and then we try to identify what the review is saying, whether it is good words, bad words, positive, negative, that type of stuff. And this is sort of reviews we are getting with that, and trying to understand whether this review is positive or negative, and so on. So again, all of this we kind of built up in the code with that. So those were the features with that. Okay, so these were some of the screenshots from here with that. Okay, so yeah, so any more thoughts on this so far?
No, this is good because this there are certain words and references which can someone like with pea brain like me can process, especially all the films and hits. So this is interesting, really interesting.
Yeah. And this is exactly what I was trying to tell you, that on one hand, AI looks like a very complicated thing. It looks very sophisticated in a way. But when you try to understand it in the problem domain, which everybody understands, i.e. movies in this case, and you go back and see that these are the things which are possible. So for example, when I went down to this thing here, I said that these are the possible problems you could do. Yes, the other possible problems you could do. Find out the reviews, find out the sentiment, find out the box office gross prediction. You can find out whether the movie is hit or not, that type of stuff. Yes, so there are many things, and of course you can find the recommendations of that. And there are many things you can do. And then there's a question of how you do that. And I think that this is where you would look at how to solve it. And of course, this is all based on real data. So of course I took the data from the internet, but we had to change it a little bit with some more things. We also took the sentiment analysis data from outside Bollywood. So I think the sentiment is not the Bollywood data set, but the other two are. The other two are, so the classification regression data sets come from there. So as you can see, these are Hindi movies with Dangal and things like this. So this is what I was trying to say to you, that it will be effectively looking at Bollywood movies and trying to find out something from within there with that. So yes, sorry, any more thoughts on this so far? Or cool? Okay.
Application and outcome, in simple language makes it interesting because your subject is very complex.
Yeah.
It is.
Yeah.
Amazing.
Yes, sorry, go on.
Sorry, I'm just, I mean, I don't want everyone to feel that why am I only interacting with you, but like what we decided is that because there's so many people, I would sort of, there are many technocrats here and some people like me, with trying to develop simple understanding.
Yeah.
But I see the massiveness of the data crunching that's required for those decisions. And, interesting, Ajit, is how this will shape future decisions and predictions. So sorry, carry on, please.
Yeah. And we are coming to Q&A quite soon anyway. So I think that's the good part about it. So I think that the Q&A question and answer session will be more interesting. I can see that there are a few questions there already on the chat with that. I haven't had a chance to look at the chat, but I think that will be quite interesting. So I think we are coming to the sort of Q&A side very soon with that. So I'll come back to some more detail on how to do this. The way you do that is that you take the data sets from many different places. They may be relational databases, they may be log files, that type of stuff. Then you put them into a cloud or some kind of a data set. Then you do a whole bunch of cleaning and transformation. So you do a whole bunch of cleaning so that the data set is eligible to be fed to a machine learning or a deep learning algorithm. Then you do the training of the model, and that's what you generally do. You try to understand what it is, and the objective is that just to try to find a label behind it, just like the human brain does. Then you do the model testing. The model testing realistically is not the same as testing as in a computer program. What we are trying to do is how to understand how it predicts something. Yes, because our problem is trying to find out whether it works from a machine learning point of view. Yes, and this is what we are trying to understand with that. And then of course you predict it. So you try to predict something and you say whether this is good or bad, and you learn from those predictions and you grow from there. When you look at Bollywood and AI and ML, by the way, this is not very new. So this has been around. So Ratan Tata funded a company called Infinite Analytics, which does a whole bunch of analytics on Bollywood. So and then there is a whole bunch of things they are looking at, and there are some links with that as well. So none of this is very new. In fact, it is very essential. As I told you, if you try to compete with Netflix today, it's going to be very hard. It's going to be almost like competing against Amazon, because they know what is a hit much more than almost anybody else, because they got 135 million subscribers and they know extreme detail about their preferences, and they can test and try different things. So this is why I think that analytics is going to shape almost everything in the future. The lesson, if there is one from here, is that don't think about it as just data science, think about it as what it means for you. Yes, so what it means for Netflix is complete personalization. Yes, by personalization, it means that it is almost that it's an individual version of Netflix for each and every person. And the reason they do that is because they are able to see or read you far more than traditional things. So this, I think, is the future of not just of the movie business, but just about everything. Because the more you are having this close one-on-one analytical relationship with somebody, the more you can shape the product almost individually to the person with that. And of course, this is how you do it. I already just recapped this one, classification regression. And this is how, these are some more notes which go into deeper things with that, mainly because if you look in the coding side of the thing, we look at sort of classification regression, what you do, especially around the sentiment analysis type stuff. With that, and then if there are numerical problems, you do techniques like removal of outliers, normalization, standardization, and so on. You check for duplicates, obviously. You check for feature encoding. You aggregate the data. You correlate the matrix. So, for example, this correlation matrix, if I go back now, this particular thing here, which is correlation matrix, if I go back here, so it is this diagram here. It is this thing here. Yes, so what I'm talking about here is that you have a number of features here, such as rating, vote, and so on and so forth. And if some of those votes, some of the features are too similar to other features, then maybe you can remove them so that they're not duplicate features in that. So many of these are mathematical techniques, and many of them apply to data, because you have to kind of create the data, create it in a certain way so that it's used for the algorithm. And especially remember that some of these are words. Yes. So for example, this lemmaization, n-gram, stemming, and so on and so forth comes from review processing. Yes. So if you look at natural language processing today, it's one of the hottest areas with that. And why do we bother about natural language processing? Because one of the problems I went back to, I talked to you about 3 problems here. And one of the problem was analysis of reviews. Yeah. So when I went here, I said to you that we're looking at 3 problems here. Yes, the 3 problems are regression, classification, and sentiment analysis. And so in this case, I'm looking at reviews. I'm looking at the meaning of the reviews, whether the words in the reviews are positive or negative. Yes, so what is the sentiment in the review? And to do that, I need to understand words. I need to convert the words into something else, into vectors. I need to analyze those and then say what it is. So these problems actually are pretty generic in terms of how you can apply them. They apply to a whole range of scenarios. And of course, we do this in code if you are interested in it. So like I said, so some people understand it with code better. I understand it with code better as well. So if you understand a bit of coding, then if you see it in code, it might make more sense to you. For some people, this is good, and this is the level of sort of problem they can look at. Just some more thoughts on this logistic regression. These are the algorithms on that we used, and with that, these are some more details about the algorithms we have used there with that. Cool. So now I will take questions. I think we have about half an hour for questions. Yes, at least 20 minutes for questions. Yes.
Ajit, yes, I've just put a note on chat. So there are some people, to asking people for questions. So you concluded your session, right? The formal session.
Yes. Yeah. Okay. So we can start taking questions now.
I was so secretly hoping you will show a small film or something a little bit at the end. But what I'll do is I'll just pick a few people who have already asked questions, and I will just shout their name out. And I will unmute them. And if you want, you can stop screen share now. So probably we can, unless you want to point something.
No, that's fine. No,
then everybody can come in the gallery view.
Yeah.
And let me just pick up somebody who has already asked questions. And I don't promise that I can take all, but let me start with the way I've noted. Shailesh Patwardhan had asked a question. And I'm going to unmute Shailesh. I noticed that you had put a comment or a question. So you're on unmute, Shailesh. You please ask your question and then mute yourself, please.
Sure. Thank you. Hi.
Yes, you can show your video also if you want to, right? But it's your choice.
No, I'm.
Okay, go on, Shailesh.
Yeah. So the classic. I mean, this is a great session. Thanks so far. I will join your coding session as well. The question I have is there a process where we can analyze video streams and, for example, analyze which are the locations which the movie has used? Does that make it popular in any way? Can we use that for analysis as well?
Yeah, sure. Yeah. So the reason I didn't cover the video is because we have very limited time. And when we go into video, we are looking at deep learning analysis. Yes. So we are looking at video analysis. To do video analysis, we have to do at least a deep learning neural network and then try to understand the frame by frame analysis of something which include effectively what is inside a particular scene. Yes. So this comes under computer vision. And if you look at some of those videos which show that they have some like a box around something, for example, you show a car and they show there's a car around that or a box around that, and this is how that works. Now, to come back to your specific question about movie locations and things like this. So you have 2 streams here. The one is the stream of the movie itself, i.e. the video, and the other one is a parallel stream which might tell you some metadata about something. So you might have GPS, for example, you might have some comments or things like that. So yes, you can do that. The algorithm which is typically used to train at is a combination of 2 things called CNN and LSTM. And the CNN bit looks at the image bit, the LSTM bit looks at the sequence bit, and you often combine the 2 together. So this is generally how you would do that.
Thank you, Ajit. Now what I'm going to do is, I have, thanks, Ajit. And I'm going to, I just spotted there are 3-4 people who actually asked question, but I'm just going to jump and to OMPEG's veteran member, and you know him, I'm sure, Dr. Bhide. I just saw he put a comment just now. Hang on, let me just see. Is he there? Yeah, M. Bhide. I was trying to look for him for unmuting. Yes, Mahadev, you are on unmute. You can ask your question.
Namaskar. Wonderful.
Namaskar.
Always. I just had a comment or observation. I totally understand the wonderful analysis that Netflix has. It knows exactly what you're doing. Having said all that, is it my personal observation or do others agree? 70% of their output is still nonsense. They still make crap movies after all the data in the world. So that they have. So I just don't, I understand the cleverness of what you are doing, but I don't understand the
Yeah.
cleverness of Netflix.
I think that Netflix is doing a classic long tail thing, meaning that what you and I might find not cool, there might be somebody somewhere who might be interested in it, and this is my analysis of that. So, for example, I can tell you that I used to think about the Netflix is primarily focusing a lot on this true crime genre. Yes, so if you look at this true crime thing, this whole Pablo Escobar type stuff, yes, the whole bunch of movies, whole bunch of series, the Narcos and so on and so forth. And this seems to be a genre which a lot of people like. I mean, this is not new because it is a real story, real gangster at some point in time, but people seem to be fascinated by this idea. So to my mind, I think that is my best explanation for that. I don't know, that's not the ideal explanation perhaps, but that is how I interpret it. Yeah.
Well, true. But my other point in this was the basic rule of statistics: garbage in, garbage out. Now, most of the reviews that happen for movies, most of them are biased. Most of the reviews are paid for, and most of the data that you collect for box office hits is also manipulated. Even so, what you are doing and your analytical thing is perfect, but the data that you're inputting, I just wonder about its authenticity.
Yeah, so I think that the way something like Netflix is looking at it, and I'm again coming to Netflix, is partly because I think that there are many more signals than just the review. So in fact, I don't see many reviews. I haven't rated many things in Netflix other than the like or not like. But I think that there are many other factors that look at it. For example, whether you forwarded something or something like that. The other thing about reviews is that they are getting more and more sophisticated at analyzing the sentiment of the wording within that. So for example, when people are, so there was a whole thing about these fake reviews which Amazon spotted. Right? About a year and a half ago, there was this whole thing where Amazon completely cut out a whole group of people because they had an algorithm which could spot fake reviews because exactly for the same reason, because they could train it on that. Cool. Okay.
Okay. So thank you, Doctor.
Thanks. Yeah.
I just put. Yeah. I was going to go to Rajiv Nadkarni. I don't know whether he's still here. He did ask a question, but I just need to check how is his name spelled. Rajjiv. Okay, I'll come to someone else who had a question, similar name, Raja, and that's it is Raja. So it could be Raja Hindustani to since we're in Bollywood. So Raja, you are on mute. Please ask your question.
Can you hear me now?
Yes, please ask your question.
Oh, thanks. Oh, you call me Raja Hindustani, which is pretty good. Okay, I'll take that as a compliment.
Please.
Okay, thanks, Ajit. I've got just one question on data science itself, or your predictive models. So now, given this, we are in this pandemic world, and neither the data of the past nor the data of the future can be relied upon. No, I mean, it's not going to. We don't know what the data for the future is going to look like, or what the model is going to look like. We don't know what's going to happen. And what the past data is junk anyways, because that can't be used for predicting what, for example, let's take Primark. Primark on one day, there was no sales. So it never happened in the history of Primark, but that's it. So how would your machine learning models will work in this uncertain world? And that's going to be for a long term. It's not going to be short term.
Yes, so I will tell you this. In fact, this is something I blogged about because when I gave a presentation to a group of real estate people about 4 weeks ago, and real estate has that problem big time at the moment. Yes, because real estate, basically everything, like you said, everything which you know is not true anymore. And how do you do that? So the solution is that there are two classes of analysis, and this is my gut feel solution. There are many other ways possibly to look at them. The first one is what is called frequentist statistics. Yes, so frequentist statistics is based on a frequency of historical data, and this is what we have been talking about. Look at the past history, look at the past buying patterns, look at the past viewing patterns, and look at that. There is a whole different class of algorithms called Bayesian algorithms. Bayesian algorithms operate quite differently. They operate on the degree of belief, and the degree of belief is something which changes or can rapidly change, depends on the scenario. So in this case, I think that in many cases, as you rightly pointed out, it is not a frequentist solution, because the frequentist solution is not valid, because the world has changed dramatically. But what is possible is that you then assign a different level of belief and then use that. So if you want to Google for something, look for Bayesian algorithm, Bayesian. Cool. Okay.
Ajit, thank you. Yeah,
Thank
Ajit,
you.
what I do
Yeah.
is to moderate the session.
Yeah.
Whenever a person has asked a question, I let them ask the question and I mute them again.
Sure.
Because the answer,
Fine. Cool.
So now I'm going to go to one more question, which I spotted. Ayush had a question. Ayush Shah. Hang on, Ayush, I'm going to unmute you. And Ayush, over to you. And okay, you are Ayush, Manchester City fan. Sorry about yesterday, please.
All right, thank you. So thank you for the session firstly. And so you talked about the hit or not hit part fits, and that comes under classification, right?
Yeah.
So what was the exact module you have used? I mean, I guess you've done it on Python, right? And what is the module you have used for the classification of the hit or not hit?
Sure. Yeah, sure. So I had listed some of them in my slides, but if you are quite interested, we can share more with it. So I think we tried SVM first, support vector machines, and then we tried naive Bayes and a couple of other ones with that. So typically, if you are kind of familiar with this thing, so what you then do is you use one algorithm to find a baseline model, and then you start tweaking it around to improve it with either having an ensemble of models or trying to change the hyperparameters and so on and so forth. So this is generally the way you really solve the problem. If for a learning point of view, I left it at a very baseline approach, meaning that I just tried one algorithm and left it at that, because I just wanted people to get used to it with that. But that's what you would typically do. You try off with something simple like an SVM, which is what we did, and then try other algorithms and try to see how accurate they are, and then try to sort of tweak them with that. Does that help? I think you are muted now.
Yeah,
yes,
thank you.
Okay.
Thank you.
Sorry, yeah, sure. Thanks.
Ajit, after this, thank you, Ajit. And after this, I'm going to one more, veteran OMPEG member. I spotted him just now with a question, Santosh Parkar. Santosh, you have a question. I'm unmuting now you. Santosh, over to you, please.
Hi, Ajit. Thanks for the excellent sessions. The question was just very sorry. This is regarding the OTT platform. Present scenario, all political or economical or other aspects of past elements are affecting industry, entertainment as well as Bollywood, means film industry. Yeah. So how AI can help to solve these problems? Because there are no certainty in any case.
By OTT, you mean over the top?
Yes, that's right.
Right. You mean something like Netflix being OTT or Skype being OTT?
Netflix being OTT, YouTube, Amazon.
Yeah. So I think that this is perhaps a wider problem. So are you approaching the problem from the perspective of the person who is not OTT?
Mix, both.
Okay, yeah.
Because
so to me, I think it is not a problem. It is just the way the industry is moving. And I think that if you look at historically, telecoms had always had this problem of Skype being, so the classic problem is that you have somebody who disintermediates you, effectively comes between you and your customer, which is what Netflix has done very effectively, which is what Skype did and all these other people do with that. I think the world is perhaps moved on a little bit from that dichotomy before. So when I was, if you look at the telecoms world a few years ago, there was all this sort of net neutrality argument and that kind of discussion. But today, I think people are sort of looking at it from a more kind of how they can build a business, whichever way of the world they are. My only interesting observation with AI is that AI tends to attract. So the main thing with AI is people, actually. So if you look at still the biggest cost with AI, or if you call it cost or investment or whatever it is people. And my interesting point always is that the the smart people tend to go to the OTTs of the world. So for example, to the Netflix of the world or the Googles of the world and things like this. And this perhaps is quite interesting. So I once had a discussion with an oil and gas person, and this person said that my industry has a lot of money, and my industry has a lot of problems, and my industry has a lot of data, but I don't find the young kids from Oxford or Cambridge want to work with me or want to work in my industry, partly because it is seen as old, perhaps seen as polluting and things like this. And I think that this is where the distinction will be, because I think I truly believe that the whole thing about AI and machine learning is that it is duplicable except for the brain power with that, meaning that the data, if you can manage it, of course. So the reason why the Googles and the Facebooks are so strong is because not only do they have data, but they have some very smart people who keep attracting to that. So this is my kind of analysis.
Yeah.
Thank you.
Thanks. Yeah.
Thank you, Santosh. Ajit, we have about 10-15 minutes. So I'm going to
yes.
before we formally
I think
close,
it's good. We
so
have
I'm going to get
a few
2-3
questions as well. Yeah.
And just for everyone, so at around 5:30, we'll bring the event formally closed so that we can stop the recording. And after that, if anybody wants to hang around, you can still do that when we'll open for a bigger crowd. Next question, I'm going to Pratik Patil had a very interesting technical question. There are two Pratiks here. Let me unmute the right one. Yeah, Pratik Patil, your question, please. I'm asking you to unmute and you can ask your question, please. Pratik, are you still there? I'm asking you to unmute. Okay, I'll read out Pratik's question.
Yeah, I can read it. The Netflix uses the Boltzmann
Yes,
neural
yes,
network.
yes, yes.
Yeah. So basically, this is the network architecture for deep learning. Yes, so Boltzmann neural networks and things like that, RBM, restricted RBMs, and so on and so forth. So typically, what people tend to use when they do, so the answer is it is not possible to know sitting from outside. Yes, because Netflix will not release their architecture of how they are using that network. So typically what people do is that they would use, I mean, since you are asking questions like that, you possibly have some background with these things. So typically you would use something like TensorFlow or Keras in Python libraries. And you start off with a core and multi-layer perceptron architecture. And then you keep on working with different architectures to improve it. Now you ask even things like GraphDB and so on and so forth. The GraphDB, the graph architectures have a different set of problems. I would not necessarily call them deep learning because graph architecture is a separate set of problems. I think maybe I can answer this question offline for you because I think you have a question behind the question, but the short answer is you would not know what Netflix actually is using in their architecture. Yes, because nobody will actually tell you this is what they do. But I'm telling you that if I were to do this, I would sort of look at it from a typical Keras or TensorFlow type problem and then kind of build the architecture on top of that.
Okay.
Cool.
So since Pratik is still not unmute, I'll say thank you on his behalf.
Okay, sure.
And I'll go to the next question. Ganesh Gadave. Sorry, I hope it's please. Ganesh, your question, please. I'm unmuting you.
Hi. Yeah, thanks for this wonderful session. My question is really on the basic question: how does sarcasm in reviews captured in sentiment analysis?
Yeah, sarcasm is quite easy to train, partly because so this again is not an easy question to answer without understanding natural language processing, but the short answer is yes, it is possible to capture sarcasm because if you can train it with that, you can assign different meanings to that. So in general, the whole NLP architecture has taken on a lot, especially with things like GPT-2, GPT-3, and the whole transformer architecture. So transformer architecture is similar to the way how you had transfer learning in computer vision, meaning that you're building on top of an existing model. So I think that it's almost sure it is possible to do. How exactly you will have to go through that.
Yeah. Thanks.
Okay.
Thank you,
Yeah,
Ganesh.
sure.
Thank you. You can go on mute. Next question. I just spotted, in fact, one of our old friends and who was part of OMPEG founding team as well, Manjiri. Manjiri, are you there? Manjiri Gokhale Joshi. I'll just unmute you.
Sure. Yeah.
Yeah. Over to you, Manjiri.
Thanks, Ani. Excellent session, Ajit.
Thank you.
I'm trying my best to apply what you said to a particular movie. Hope I'm right. And that's the question. So classification hit.
Yeah.
I'm trying to apply it to the movie Dangal, which was one of the biggest hits, and I think most of us must have watched. So if you look at the hit and if you look at the regression patterns in that kind of movie, the typical pattern you had was Amir Khan usually has been giving hits, the biopic, which is one of the features which working very well. If you look at the attributes, it's good songs. They definitely had good songs.
Yeah.
A lot of sentiment of the national pride, which was doing well. Again, another attribute. The anomaly was there was no hero. I mean, apart from Amir Khan, there was no traditional, typical Bollywood hero. But unfortunately, after Dangal doing so well, and it's analyzed the way you explained, the other movies which followed this, the example of Panga last year on the returning kabaddi player, they failed, completely failed, because after everything going right, the way you've said. So my question really is that isn't deeper learning, again, to go back to your definition of deep learning, more deeper learning required and needed for us to be, when I say us, the Bollywood industry, to be explicitly able to train an algorithm? Exactly, I'm trying to use your definition of what you said. So that's my question.
Yeah. So I guess you're right that there are many different factors which come into play. I must admit that I have not seen Dangal. I know that this is a few people which will not like this because especially I think Sushil had a couple of sessions on this one time ago. But I think the point I'm trying to make here is that, and as you have made it as well, that there are a number of factors, and this is exactly why so much data is available and so much analysis is available within that. So for example, the kabaddi one, I think you would have to see it as the genre being too close to each other. Yes. So is somebody trying to look at a similar concept movie, and are people tired of that, and so on and so forth within that? So the short answer is there is no easy answer to this, but the point I'm trying to make is you are analyzing it the correct way. I'm trying to tell you that. Yeah. So the point is that I think that almost all the problem, this was partly the whole point of taking the session like this, is that when you see the world in this way, then you see that it is not magic. It is not rocket science. Most of AI or machine learning does come down to sort of understanding the factors behind something, or more specifically, the hidden factors behind something. So there is maybe a hidden factor which you are not there. I saw you talked about anomalies as well. So you are clearly reading all what I have said in that, which is good. Yeah.
Okay,
thanks. Thank you. Yeah.
Ajit, thank you so much.
Yeah.
And I'm sure we'll go on. Promise me that very soon you will see Dangal, because I'm sort of an unofficial representative of Bollywood here, as all of our representative technology. I'm taking that flag high. Okay, Ajit, what we'll do is we'll take one question, and then we have a couple of OMPEG announcements also, and then we'll close the session and people can continue.
I'll hang around. I'll hang around afterwards as well, and we can cover all the questions here with that. Yeah.
So I'm going to the chat board. Rajiv is not there. So Rajiv, I spotted Kamlesh had a question. Kamlesh, are you still there? Kamlesh Devkar had a question. I'll unmute him. And Kamlesh, this will be the last question we take, and later on after the sessions.
Good evening, guys. So firstly, interesting session, Ajit.
Thank you.
Really appreciate it. I have a very particular use case in place. So for example, there are a lot of there's a huge problem in the market, which is users know what to watch, but they don't know where to watch it. And hence the whole business model or line of the vertical of business of OTT aggregation, content aggregation has come into picture.
Yeah.
So what I'm trying to understand is, imagine I have a guest user who's coming to my portal, who has an intent of watching a particular movie or looking for content of a particular movie star, director, for instance. They hit the query on the portal, and I now want to create recommendations or give recommendations based the intent of the user for the upcoming sessions or whatever time possible we have in hand. The only bug or problem that I see is that it's not a registered user, it's a guest user. So how do I approach this, and how do I maximize my usage of the portal, as well as how do I give them more specific recommendations so that I I get the
Yeah.
user.
So this is what is called, what I described as a cold start problem. At some point I mentioned the word cold start. Cold start meaning that you don't have any history behind this thing. Yes, so this is a guy who has come new, and the cold start meaning you start in the car from cold, so it is, you don't know what came before it, and to do that. So the general way recommendations work is that they work either on your past history, or they work on people who are similar to you. Yes, so in this case you have neither of them, meaning that you don't know who is similar to this user, and this user does not have a past history with that. The best way you do that is that you have to look at factors which might influence, which you might get from just looking at either a postcode or something like this. So you would have to look at factors which are not there with that. Also, I would say that this is an 80-20 problem, meaning that if you're running a business, I would suggest that trying to spend too much effort or trying to write an algorithm to suggest something to this guy may not be so effective money-wise, as opposed to all the customers you know your data about. Because this guy, you are never going to be able to do much with him or her, because there isn't too much of data with that. On the other hand, you have about lots of them on your website currently, you know a lot about. You might as well focus on getting them with that. So this is the classic one. I'll tell you one interesting story before I hand over back to Ani. So Netflix had a Netflix challenge. I don't know how many people know about this. So this was about a few years ago. And the thing about the Netflix challenge was Netflix open sourced a whole bunch of data and asked some very smart people worldwide to say that, okay, how will you solve this problem? And the geeks and the people like me, like Oxford and Cambridge and things, they sort of went on a very mathematical output, and they produced a solution. The solution worked, but Netflix could not use it because it was too hard to implement it. My point is that quite often what is called data trumps the algorithm. Yes, so it is much better to get more data about something than to write a more complicated algorithm behind something. So these are data-driven algorithms. Yes, so for example, if I'm writing an algorithm to look at the behavior of a spacecraft or look at the behavior of a ball in the air, this is not a data-driven algorithm typically. This is a trajectory-driven algorithm. In this case, what you're looking at is data plus algorithm with that. So there's the two factors here, whether you could spend a lot of time writing complicated algorithm or opposed to get more data. So in this case, it's a business solution, I would say. Don't worry too much about this person. Good.
Ajit, thank you so much, Ajit. Now before Ajit, thank you.
Yeah,
and I've informed everyone that I'm not coming between you questions and Ajit. We will have time after that, but there's a formal session. Ajit, before we, I have to formally thank you, but before that, what I'm going to do is we have a little announcement from OMPEG, and I'm going to do that before the vote, vote of thanks, because if we close the session and we say thank you, then people will go. And in the Bollywood analogy, since you are still on screen, the star is still on screen, we might as well get that quick announcement done. Okay.
Okay, sure.
So I'm going to get Devrat Vaidya from Midlands, talking about something exciting that's happening in OMPEG. Devrat, over to you, and you will be unmute now. Go on, Devrat, please.
Thanks, Sunny. Hope everyone can hear me.
Yes, go on.
Thank you. Good evening, all. Just want to start by thanking Ajit, first of all, for such a fascinating session. I'm sure everyone who has joined the session this afternoon has enjoyed it, has found this session very informative and very interesting. So thank you really, Ajit, for that one. The announcement that Ani has referred to, basically, we are continuing on the OMPEG's successful journey that OMPEG has started of promoting the entrepreneurship by networking professionals and entrepreneurs. We are excited to announce that we are about to launch the OMPEG Midland chapter. The launch event itself is arranged on Saturday, the 29th of August at 4 p.m. in Coventry. Unfortunately, due to the current social distancing restrictions, we are not able to accommodate everyone at the venue. And entries at the venue are limited to invitee only. However, we have availed the use of technology for everyone to join the launch ceremony through Zoom. The details of the events are obviously on the screen that Ani has put up. The event link for Eventbrite link for registration will be shared in next day or so. But if anyone needs any further details, please feel free to contact any of the organizing committee members. Hence, on behalf of OMPEG Midland chapter, I would like to invite all of you to join us on the grand launch ceremony on Saturday, the 29th of August. And we hope to see you all on the Zoom on that day. So thank you all.
Devrat, thank you very much and wish you all the best. And Devrat, it would be useful if there are people from Midlands around here, you can share your number on the chat. So you are part of the Midlands volunteering core voluntary team, so they can contact you. Is that okay with Devrat?
Absolutely. I'll just do it now.
Thank you so much. And Ajit, now, thank you so much for a fabulous session. I absolutely loved, because you probably used the word Bollywood at least 100 times. As far as the AI part was concerned, I used to be in the world of technology, not so for last 8-9 years. So I've understood some basic concepts, however complex they are. It was useful that you sort of put initial in layman's term and then built up how complex it is. Your picture that you showed about, it almost reminded me of that Carl Sagan thing, the pale blue dot thing, that you know where your place is, but you are part of a complex world, and it's best to know where you start. It was very interesting that you used AI, machine learning, connecting to Bollywood and films. And as many people who ask questions have suggested about how opinions are shaped, how decisions are taken. It was very interesting to know what goes behind it. And it's also interesting to understand what future might look like, because as all these smart engines like Netflix and Amazon, they use AI, use our data and shape future for us, where we think that all of us would think that this is what choices we have made, but it's actually no free choice at all.
Correct.
So thank you so much for deciphering that. On behalf of OMPEG, just a small token of gesture we always do is thank you. And you like pink color, right? This pink color. So we use some human intelligence for that. Thank you so much for giving your time, and wonderful always to hear you. And on behalf of OMPEG, thank you so much for conducting this session. So with that, at that stage, I'm going to stop the recording now, and then we'll open the session. If anybody wants to hang around, please do so. I'll unmute, I'll follow the same pattern. And anybody wants to join OMPEG, Ravi said at the beginning that OMPEG stands for Overseas Maharashtrian Professionals and Entrepreneurs Group. We started 4 years back with single mission to spark entrepreneurship in Maharashtrian professionals and create a platform to change the image of Maharashtrians as frontrunner business leaders. If anybody wants to join OMPEG, it is very simple. I'm going to put that on chat window right now. You heard today's session. It makes sense. We arrange many such events, learn from each other, cross-pollinate ideas, and prosper. That's the idea. So thank you very much. I'm going to stop the recording, Ajit, now, and then we'll open for any further discussion. Thank you again. Anybody wants to drop off, you can drop off now.
Thank you again. So I'm going to take one interesting question here.